You wouldn't plan on going 75 miles for offshore fishing for the day without first checking your fuel and hopefully checking your oil. But what about your batteries? It is absolutely critical that your boat utilize marine grade batteries. Automobile batteries are not designed to handle the jolts and vibrations seen in boating, nor tolerate harsh marine environments. Battery selection is also dependent on the size as well as number of engines present, as well as the boat's electrical demands. Certain manufacturers may have battery recommendations, such as AGM batteries in the Mercury Verado series. Batteries do not generate energy. Batteries serve as a reservoir and through a chemical reaction between lead and sulfuric acid are able to release stored energy. When selecting a battery for your boat, it's important to recognize certain ratings, such as the amp-hour capacity rating, which is the total amount of amps discharged over a 20-hour time frame. For instance, in this 100 amp-hour battery, that means this rating can deliver 5 amps over a 20-hour period. Another key rating is the marine cranking amps, or the MCA. This is the number of amps that the battery can deliver over a 30-second period while maintaining a 9.2 volt terminal voltage. And finally, the reserve capacity is the number of minutes a battery can deliver 25 amps while keeping its voltage above 10.5 volts. A marine-grade battery should have a reserve capacity of greater than 100 minutes. Modern sealed lead-acid batteries come in both an engine starting type, which can deliver a large burst of energy over a short time frame, as well as deep cycle batteries that produce a steady current over a long time frame. Deep cycle batteries can also undergo repetitive full energy discharge and charging cycles. AGM, or absorbed glass mat batteries, can function as both a combined starting as well as deep cycle battery. AGM batteries provide more consistent energy delivery and are critical for powering engine and helm computers for digital throttle and joystick controllers. Marine-grade lithium cells are increasing in popularity. These batteries provide constant and more power delivery with up to 2 times faster charging rates. The batteries are lighter in weight and can last 4 to 10 times longer than traditional lead-acid batteries. Unfortunately, these batteries can cost up to $2,000 per cell. While your engine is running, your batteries are being charged. An alternator produces an AC current that is rectified to a direct current and regulated between 14 to 14.5 volts. Some engines utilize a slightly different technology of a stator located under a flywheel, but still utilize a separate regulator and rectifier. Pay attention to your voltmeter. Once your engine is started, you should see around 14 to 14.5 volts, depending on the size of the alternator and the RPMs. If you notice that your voltage is below 12 volts or above 15 volts, this signifies an immediate problem with your charging system. When your engine isn't running, one way to maintain good battery health is by using a trickle charger. This technology offers an ideal slow charge, which is usually rated at 1/10 of the amp rated capacity. An automatic battery charger is extremely useful if your boat will be out of the water for an extended period of time. An onboard integrated charging system is a must-have for multiple battery banks or if you have AGM batteries. It maintains ideal battery health. When the engine is not running, a voltmeter provides a very limited and non-dynamic testing of a battery status. Load tester places a dynamic load similar to an engine starting onto a fresh battery. One should not see the voltage drop below 9.7 during this process, and when the load is removed, the voltage should return back to near starting voltage. This device generates tremendous heat. Be cautious. This $35 battery analyzer offers a tremendous amount of information which can gauge the state of health of a battery. After inputting minimal data, this device can tell you if your battery is good, needs to be charged, or needs to be replaced. It can even determine the state of health and state of charge of the battery. Stray current is a premature discharge of voltage across a dirty insulated battery case. Despite the looks of this battery, no stray current was identified. However, a wet, dirty battery can easily demonstrate stray current, especially at the insulated rubber covers over the posts where 12 volts was detected. So your fishing poles are secure and your cooler is packed. You turn the key and your engine doesn't start. You confirm the shifters in neutral and your safety lanyard's intact. The next obvious cause is a failed battery system. Sometimes the battery system failure is quite obvious. Sometimes battery health has just been neglected. Not only do you evaluate the batteries and cables, but battery switches, isolators, power posts, terminals, and lugs could also be involved. After examining any obvious findings on the battery, I favor returning back to the engine and performing a load test at the terminal endpoints, which are illustrated here in letters B and C. A marine starting motor requires approximately 9 to 9.5 volts during a load. The marine engine-based computers, such as a PCM or ECM, require anywhere between 10 and 10.5 volts during a load to be operational. Thus, any terminal voltage drop below 10.5 volts at the engine will result in failure of the engine computer, generation of multiple fault codes, or even a no-start scenario. One of the most common causes of voltage drop in the marine environment are corroded terminals. If the terminal appears to be superficially corroded, this can be cleaned with a wire wheel. However, if there is evidence that the corrosion has extended onto the wire, then the cable needs to be cut back and the terminal lug needs to be replaced. Sometimes what appears to be superficial corrosion at the end of a terminal may actually be corrosion that is spread down the insulated sheath and extend quite a distance. In this case, the entire wire needs to be replaced. The terminals on the back of your battery switch can also yield unsuspecting corrosion. Don't forget to examine your terminal ground leads at both the battery and down to the engine for other sites of potential corrosion and voltage drop. Many boat manufacturers choose to install power posts, either located in bilges or aft compartments. These usually tend to live in moist environments and often can be a source of unrecognized corrosion and voltage drop. At least 1 to 2 times a year, clean your battery case with a mixture of baking soda and distilled water, followed by a distilled water rinse. This will minimize any stray current across your battery case. Use a steel brush to clean off any visible corrosion from the battery post terminals. Ensure that your terminal lug nuts are tight and secure. You should have no more than 3 terminals per any battery post. If you do happen to have more than 3 terminals, consider getting a battery terminal block, which will safely secure up to 8 terminals per battery. To prevent wire fracture, make sure your fusible links are also secure. Complete your maintenance by applying anti-corrosion spray to all terminal points throughout the entire power system. Now that you understand battery health and maintenance, there should be nothing holding you back from enjoying a beautiful day offshore. Do not hesitate to contact us if we can be of any further service for your boat repair, engine service, or marine electronic needs.